Hello friends, welcome to Engineering Made Easy. I am Lalit Vasist. In this video lecture, we will discuss the delta modulation and we will see its basic concept, what is delta modulation, the main formula behind this concept and the waveform of delta modulation. Okay, so this is slope overload distortion and granular noise, or known as idle noise, will be discussed here. We will also see the beautiful diagram of this quantization errors that are encountered in delta modulation, these two, slope overload and granular noise. And after that, in the next video lecture, we will also discuss the adaptive delta modulation techniques. Adaptive delta modulation is used to overcome these two defects, these two drawbacks of delta modulation. This is the adaptive delta modulation. Here is the adaptive delta modulation. We will see the basic concept of adaptive delta modulation along with the beautiful waveform of this adaptive delta modulation. So let's now start with the delta modulation. Okay, in the last lecture we have seen the pulse code modulation, PCM, and now we understand that the in PCM we transmit all the bits that are used to code a sample. Hence the signaling rate and the transmission channel bandwidth are very large in pulse code modulation. So to overcome this problem, we use delta modulation, where only one bit per sample is transmitted. So this delta modulation is a technique to convert analog signal into digital signal. So we will see here the basic concept of delta modulation and also the waveform of delta modulation. So let's start. So in delta modulation, the present sample value is compared with the previous sample value, and this result, whether the amplitude is increased or decreased, is transmitted. Let me explain it to you. Actually, let me take the help of waveform so that you can get the concept easily. Now look at this waveform of delta modulation. Here, this is the analog signal in a sky blue color. Okay, this waveform is the analog signal, the xt signal, input signal. Okay, this is a graph between amplitude and time. Now we want to convert this analog signal into a digital signal. Okay, here its output is 0 1 1 1 1 like this. So it is a stream of binary 1-bit sequence. It is a stream of binary bits. It is a digital signal. So we have converted this analog signals shown in a sky blue color into this digital stream. So how we have done this? It is equivalent to this one. Now look carefully. This analog signal in blue has been approximated by this staircase like signal. This is the approximated signal for this analog signal. Okay, so how it takes place? Notice here that this step size in this staircase like signal, approximated signal, this is the step size. This vertical height is the step size, and it is known as, it is denoted by delta. So it is kept fixed in delta modulation. Okay, this step size is constant. So to understand it, let's see the basic concept that has been used here to convert this analog signal into digital stream. Okay, so let's first understand this mathematical expression. This is the basic concept. Here it is written E NTS is equals to x of NTS minus x cap of NTS. So what these terms mean? Here x NTS is sampled signal of xt, while x cap NTS is the last sampled approximation of the staircase waveform, while E of NTS is the error at present sample. I will explain you all these three terms in the waveform, what they stand for, and this x of NTS is nothing but the sampled signal of xt. How it is? Here you see that this analog signal in blue has been sampled. Okay, these are the samples. These vertical lines are cutting it into various samples. These samples are in time domain. Okay, so this value x of NTS is this sampled value. These are the sampled values. This part from here to here, this within these two within this sample from here to here, from here to here and from here to here. That is the part of this analog signal between these two vertical lines, black lines. Okay, so this is x NTS, and x cap NTS is the last sample approximation of the staircase waveform. This is the staircase waveform. Okay, this in pink color is the staircase approximated waveform, and the last approximated waveform means, if I talk about this part from here to here, this x NTS part, then the last approximated waveform for this one is this one. So we here compare to find the error at present sample. We compare this part and this blue part. Okay, so if the difference is positive, that is, we subtract this from this blue part. Okay, this analog signal, this sampled signal. So we see here that the value of this is more than this. So this minus this gives you the positive result. So we increase this staircase waveform by one step, delta. Now this is the approximated value for this part. Okay, this blue part has been approximated by this pink colored line. Okay, so this is the approximated value. Now we will compare this approximated value with this next. So here this sampled value is again more than the last approximated value of this staircase. So we again increase the staircase. We again increase this approximation by one delta, that is one step size, and in this way you see that it is continuously increasing waveform. So we keep on increasing it by delta. But now here observe that here the approximated value is higher than the here this is the signal, this is the sampled signal, and its previous approximated value is this one. So this previous approximated value is higher than this one. So the difference, this minus this, is negative. So here we decrease the we decrease this by delta. This approximated staircase signal has been decreased by delta. So now look at this and the next signal. So if you compare this, then again this sampled signal value is lower than this last approximated signal. Okay, so we again decrease it, and since it is a continuously decreasing part of this analog signal, so this keeps on decreasing. So what rule we are following here? Actually, whenever the x NTS, that is a sampled signal of xt, this part, this in blue, is more than the previous approximated signal, then we increase the step size by delta and transmit 1 is transmitted. But when the sampled signal xt is lower than the last approximated signal, like this, okay, last sampled approximation of the staircase waveform, then we decrease it, we decrement it by delta. So in this way it follows, and when we decrease it by delta, then 0 is transmitted. So in these parts you see where it is increasing, 1 has been transmitted. We transmit, we represent it by 1, and when it is decreasing, then the staircase is continuously decreasing, as the next value is definitely lower than the previous sampled approximated staircase waveform. So and 0 is transmitted. But look at this point here, this is the signal, and here the last staircase approximation is lower. So again this, in this case we increase the step size and 1 is transmitted. So hope you got the concept here. Here what is TS in x of NTS and x cap of NTS? TS is the sampling period. This is the sampling period from here to here, and delta is the step size. So this is, in this case we can convert this analog signal into a binary 1-bit sequence, okay, with the help of this approximated staircase signal of this analog signal. So in this way the analog signal has been converted into binary 1-bit binary sequence into digital output. But this delta modulation has a problem of slope overload distortion and granular noise that we will discuss in later video because of this fixed step size. And to overcome these effects, adaptive delta modulation is used. In the adaptive delta modulation, we do not use fixed size of this step size. We vary the step size as per the changes or variations in the input signal. So the errors, these two quantization errors are reduced in adaptive delta modulation. That's why it is known as adaptive, because this is the next advanced form of delta modulation which has been adapted, which its step size has been adapted according to the variations in the input signal. So the noise or the error, the quantization error is reduced. So in the next videos we will discuss these two types of quantization errors and also the adaptive delta modulation. So keep watching and don't forget to like and subscribe my channel Engineering Made Easy, and I recommend you to watch my next two videos also so that you can grasp the whole concept. Okay, these next two videos will be the part of this video. So I don't want to make it very large, this video, so you can visit my channel, and I will also put the link of the next two videos in this video's description, so you can watch it by clicking on this. So thanks for watching. Don't forget to subscribe and like the video. See you soon in the next videos. Till then, bye bye. Friends, for more such videos you can subscribe my channel Engineering Made Easy, and please don't forget to like and share the video if you liked it. For more detailed information, you can visit my blog. See you soon in the next video. Till then, bye bye.